Most medicinal mushrooms have a pleasant, mild, or even umami flavor profile. Ganoderma lucidum, commonly known as reishi, is famous for the exact opposite, an aggressively woody, intense bitterness that coats the mouth. Yet, despite a flavor that makes it almost impossible to eat raw, it remains one of the most prized therapeutic fungi on the planet. There is a discrepancy in the modern consumer market. If you buy a generic reishi supplement today, the flavor is often completely neutral or even sweet. This raises a central question. What specific chemistry creates this extreme bitterness, and how does that flavor profile relate to the way these mushrooms are processed? Our sense of taste acts as a real-time chemical analyzer, detecting the concentration of the mushroom's most valuable compounds. To find the source of that harsh flavor, we have to look past the human tongue and zoom into the microscopic architecture of the Ganoderma fruiting body and its spores. The mushroom is densely packed with fat-soluble molecules called triterpenes. These specific compounds are the direct source of the bitter taste. The sheer volume of these compounds is staggering. Scientists have isolated well over 100 distinct triterpenes from this single mushroom species. This diagram illustrates a highly oxidized subgroup of those triterpenes, known as ganoderic acids, specifically types A, B, and C. These highly oxidized structural points on the molecule bind directly to human bitter taste receptors to trigger that intense signal. The denser this web of ganoderic acids becomes, the harsher the bite. That density provides a direct molecular blueprint of the mushroom's therapeutic power. Ganoderma doesn't produce these complex acids by accident. The mushroom grows slowly on decaying logs, competing for survival in a dense forest habitat. Because it takes months to mature, the fruiting body is vulnerable. Insects, snails, and herbivores are constantly scanning the forest floor for their next meal. The extreme bitterness is an engineered evolutionary defense mechanism designed specifically to be unpalatable to these predators. The massive concentration of triterpenes acts as an invisible chemical force field. It deters consumption, keeping the mushroom intact long enough to safely release its spores into the wind. The exact chemical trait that evolution built to repel predators in the wild is the precise source of the biological potency humans are trying to harvest. Getting those compounds out of a tough, woody mushroom and into a digestible form presents a severe industrial manufacturing challenge. The core bottleneck is solubility. Because triterpenes are inherently fat-soluble, they resist standard extraction methods. A hot water extraction column dissolves simple, circular beta-glucans for immune support, but complex, bitter triterpenes stay locked inside the mushroom fibers. To extract those fat-soluble triterpenes, an ethanol process is required. This breaks down tough cell walls, carrying them into the final batch. The chemistry of the extraction method dictates whether the final product contains the full spectrum of medicinal power or remains a hollow shell. In traditional herbalism and modern quality control facilities alike, flavor remains the ultimate actionable proof of a successful extraction. A mild, sweet, or neutral-tasting reishi product indicates either a failed water-only extraction or a product that has been thoroughly stripped of its active compounds. A properly standardized ethanol extract provokes an immediate physical reaction. A single drop should cause a sharp, visceral squint. That harsh, woody bite identifies the presence of adaptogenic, highly oxidized ganoderic acids that have been successfully captured and concentrated. A premium Ganoderma extract delivers the immediate sensory shock of nature's defense mechanism hitting the palate, providing tangible proof of its potency.